Succession. How do ecosystem communities change over time? Ecosystem communities change over time, especially after disturbances. As some species die out and new species move in, these are ecological succession, a series of changes that occur in a community over time. Over the course of succession, the number of different species present increase. Volcanic explosions can create new land or sterilize existing areas. Retreating glaciers can have the same effect, leaving only exposed bare rock behind them. Succession that begins in an area with no remnants of an older community is called primary succession. This is Mount St. Helens before the eruption in 1980. This is Mount St. Helens after the eruption. The cloud is where the mountain peak used to be. And this is Mount St. Helens 10 years later. And now today, you can see many more species have returned. Another example is Glacier Bay, Alaska, a retreating glacier exposed barren rock. Over the course of more than 100 years, a series of changes has led to the hemlock and spruce forests to now be found in what was the barren rock. Changes are expected to continue in this community. The first species to colonize barren areas are called pioneer species. One ecological pioneer that grows on bare rock is lichen, a mutualistic symbiosis between fungus and alga. Over time, lichens convert or fix atmospheric nitrogen into useful forms for other organisms, break down rock, and add organic material to form soil. Certain grasses, like those that colonized Krakatau early on, are also pioneer species. Sometimes existing communities are not completely destroyed by disturbances. In these situations, secondary succession occurs. Secondary succession proceeds faster than primary succession, in part because soil survives the disturbance. As a result, new and surviving vegetation can regrow rapidly. Secondary succession often follows a wildfire, hurricane, or other natural disturbance. We think of these events as disasters, but many species withstand them. Although forest fires kill some trees, other trees are spared, and fire stimulates seed germination in some species, speeding up ecological succession. Secondary succession can also follow human activity like logging and farming. This series shows a secondary succession taking place in abandoned fields in the Carolinas, Piedmont. Over the last century, these fields have passed through several stages and matured into oak forests. Changes will occur for years to come. Every organism changes with the environment it lives in. One model of succession suggests that one species alters its environment. Other species find it easier to compete for resources and survive. For example, as lichens add organic matter and form soil, mosses and other plants can colonize and grow. As organic matter continues to accumulate, other species move in and change the environment further. Over time, more and more species can find suitable niches and survive. Do ecosystems return to normal following a disturbance? Secondary succession in healthy ecosystems follows natural disturbances, and they often reproduce the original climax community eventually. Ecosystems may or may not recover from extensive human-caused disturbances to reform the climax community. Ecologists used to think that succession in a given area always proceeds through the same stages to produce a specific or stable climax community, the original community. Recent studies, however, have shown that succession doesn't always have the same path, and that final climax communities are not always uniform and stable. Secondary succession in healthy ecosystems following natural disturbances often reproduces the original climax community. Healthy coral reefs and tropical rainforests often recover from storms, and healthy temperate forests and grasslands recover from wildfires. However, detailed studies show that some climax communities are not uniform. Often they have areas in varying stages of secondary succession following multiple disturbances that took place at different times. Some climax communities are disturbed so often that they can't really be called stable. Ecosystems may or may not recover from extensive human caused disturbances. Clearing and farming of tropical rainforests, for example, can change the microclimate and soil enough to prevent regrowth or the original community. The following three pictures may help illustrate. Amazonian rainforest before deforestation, during deforestation, and the border of deforestation between the fields that were cleared and the original forest.